recording it. I'll share my screen. Let's see how this works. Been a wild last week and this week, so I hope things have calmed down for everybody. I don't know how this is going to work. We're going to play with it, but it beats the document camera not working half the time. So we're going to look at I got to get it calibrated. 7.2. Sometimes I can write really neat, sometimes I can't. But we're looking at number lines. I have to figure out how to calibrate it.
You figured out, Karen?
No, I can't figure out how to calibrate it.
How to calibrate it,
So because when I write, and I go way up, up here, I'm way up there.
Oh.
So I have to come down the mid screen.
Which means that as you scroll down. See what happens when you scroll down and where you can wind up. Okay, now write something. You're gonna be able to? I was gonna say, put those 3 dots, that might help me.
About 3 dots.
Well, you had 3 dots when you were. Okay.
How my pen's gone to.
Okay.
Carry my pen's back, so.
Okay. Now write something else. Okay, see those 3 dots right there? I thought maybe it would show me something that I could.
And if I go down here and click on the workspace, and do a full screen. Let's see if it doesn't. What will happen? I do it. I like it.
You have to pick a pencil. Pick a pencil. Now try it.
Yeah, but I'm still not.
Well, you were better there than you were on the other one.
Whiteboard will not be recorded.
Oh.
So that's. Yeah. Okay, let's go back. I don't. guess I just have to watch the board.
Okay, that's perfect this time. It's working right this time.
But I'm still,
Hasn't it come down so far? Now, I don't really know.
I don't know either. I just have to watch what I'm writing.
You're gonna have to tell her. Tell her when it don't, but y'all can't see
You
something.
can't see it, you gotta tell me.
All right, I'm gonna head to the house.
All right, thanks for stopping by.
You're gonna have to keep her honest on it.
They do a pretty good job keeping me pretty honest anyway. All right, so we're looking at 7.1 and 7.2 out of the textbook today, and it's real number lines and absolute value. We're going to concentrate more on the absolute value than we are in the number line. I'm going to double check and make sure I am recording. I'm still recording. Josh, if you can't see something, make sure you let me know. So we have positive and negative numbers. If you look at a normal number line, okay, pretend, well, let's erase that. So we're going to pretend this is a straight line. No, we're not. It's too crooked. Let me see if I can. So we got a number line. And if I make a mark right in here, go back to my pen. We're going to call this 0. Everything to the left are negatives. Which most of y'all already know this. It's not. And then everything to the right are my positive numbers. And then these go on forever in both directions. We've got what we call positive infinity and negative infinity. Okay. And the deal with the number line is that however many steps I take, it's -4. I'm going -4 to the left. I'm taking 4 steps from 0 to get to -4. So this shows that the absolute value of -4 is 4, because it's how many steps does it take me from 0 to my number, okay? And on the number line, if I go, I'm going to change pen colors, to the right 4 places, and I make 4, and my hops aren't right anyway. Call this +4. I'm making 4 steps to the right. Y'all just have to go with me on writing. I'm practicing. But the absolute value of +4 is still 4, because from 0 to +4, I'm still making 4 steps. Okay. So it doesn't matter if you take the absolute value of a positive number or a negative number, the absolute value is always going to be positive. And I use the example, if we talk about ground level, and we call ground level being 0, we dig a hole 2 feet deep. So we're 2 feet below ground level. So we could write that as -2 feet, meaning that I'm 2 feet below ground level. But how far down did I really go? I went 2 feet, right? You can't travel a distance of -2 feet. That negative tells you the direction you're going. Okay, so I'm going the opposite direction. So if I'm going down 2 feet, that's negative, that's the opposite of up. If I'm going up 2 feet, that's positive, I'm 2 feet above ground. So we have what's called positives and negatives, and we have, well, opposites. So if we, whoops. So if we have opposites, so the opposite of -7 is +7. Okay. So, and if you add your opposites together, they will always equal 0. So -7 plus 7 equals 0. Your opposites will always equal 0. They're always the same distance from 0. And it works the other way. If I give you a +4, what's the opposite of +4? -4. And if I take +4 plus -4, I'm still going to get 0. Okay. Now this stuff, like I said, this stuff y'all know. It's in the back of your mind. You just got to bring it to the front. Matter of fact, probably everything we've done in here so far this semester, you've learned before. It's just remembering it. Okay. A little more, I guess, just kind of bookkeeping skills before we get into solving actual problems. Are inequalities. Our inequalities are the symbols. We have our greater than. We have less than. And one thing I've always been taught, if you're wanting to use the less than sign, it opens up to be an L. But you're always opening to the larger number because the gator eats the larger number. My eighth grade, ninth grade students taught me that with inequalities. I'm like, okay, greater than or less than is the L, so greater than is the opposite. And they said, Miss Young, we learned in elementary school that the alligator eats the larger number, so it always opens to the larger. If I put, oops, this is less than or equal to. If I put this little bar under it, it makes it less than, or it makes it equal to. So I have the less than or equal to. So it's got that little bar under it. Well, the other way, I have greater than or equal to. I might be able to work with this. So if I looked at, say, using our opposites. Let's negatives, let's not use the opposite. Yeah, let's use the opposites. -7 and 7, even though they're opposites. But which one's greater? The 7. So I'm going to put a greater than symbol. Okay. And that's -7 is less than 7. What if I used like 3 and 0? 3 would be greater than 0, right? And these are all true. Now sometimes you'll be asked if they're true or false sometimes. So if I gave you -3 is greater than 0, is that true or false? False. False. Because -3 is not greater than 0. If you draw a line through it, that means not. So I could write it as -3 is less than 0. That would be true, wouldn't it? And the symbols are always read left to right. don't want this to take it all the way down. Should have probably done that earlier. Figure out another way to do this. So does everybody have everything down that you need? Let me erase real quickly. So it says one of the exercises you may have, it gives you a set of numbers. And it says to graph them on the number line. So I have 2, -3, 0, -1. So let me see if I can draw a number line. Nah, it wasn't. Now, in Hawks, they will have a number line and you're just going to put them on the numbers, like they will have these already drawn in. And they will tell you that probably this one is 0, or they'll give you some numbers. So I'm choosing 0. And then we're going to look. So I need to graph, put 2 on the number line. So I'm going to start at 0 and I'm going to go 2 places to the right, and that's 2, +2. And then I'm going to go to -3. I'm going to go 1, 2, 3 places from 0 to the left, and I get -3. So I've already got 0 there. Where would -1 be? One place to the left, one place to the right. To the left. Y'all have got this, right? Okay. So another thing that you might be asked is fill in the blank expression. What kind of inequality am I going to put there? Less than, greater than, equal to?
That 19 is greater than -20.
Yeah, 19 is greater than -20.
Okay.
So if I'm reading it left to right, -20 would be less than -19. But you're going to choose the symbol that opens to the 19 because -19 is greater. Okay. Here's another one that just looks kind of like y'all will overthink it. Positive 5.6 and then negative 8.6. Right, the 2 negatives will come together and make a positive because negative times a negative is a positive. So which symbol would I use, less than or greater than? Remember, it reads left to right. 5.6 is less than 8.6. But if I hadn't done that one, somebody would have overthought that one, wouldn't they? And that's okay. I overthink a lot of things. All right. Now we talked about the absolute value of -4 is always going to be the positive, right? But what would be the absolute value, and I'm using x because it's an unknown, of +8? What? You know it's going to be 8 and 8, right? Because the absolute value of +8 equals 8. But what else? What other number can I put in here that's also going to equal a +8? -8. So if I get something like the absolute value of what number is equal to 8, it's going to be a plus or minus 8, or you're going to write it as 8 and -8. Something like that. I don't know if Hobbs will let you put the plus or minus sign in or not. Okay, so let's look at a different one. Look at the absolute value of what number is -23. And I warn you, it's a trick. Now, what did I tell you about absolute values? What are absolute values? Always positive. So am I going to have a number that I can take the absolute value of that's going to give me a negative? No. So this one is no solution. Because you can't take the absolute value of any number and get a negative number. Now, where I could have something like that is if I had a negative absolute value of x equals a -23. Okay? So what I'm looking at is that my negative on the outside of the x is going to make my answer negative. So if I took the negative absolute value of +23, I'm still going to get a -23 because of the negative on the outside. If I take the negative absolute value of a -23, I'm going to take the absolute value of -23 first, and I'm going to get 23. But this negative is going to come over and make it negative here. Okay, so if there's a negative on the outside, the absolute values are like brick walls. You can't take it to the inside, okay? You can't pass it, it's like a wall. So it has to kind of follow over. All right, so any questions? That one's for y'all, for some of y'all. So how good are y'all at saying -6 plus 8? Well, there's nothing, I mean, it's equal. So, yeah. What I'm going to look at is a number line. Here's 0. I have 1, 2, 3, 4, 5, 6, 7, 8. +8, right? And I've got 1, 2, 3, 4, 5, 6, -6. So I'm adding them together. So now remember how to do this. If I'm adding them, I'm taking this one cancels this one. This one cancels this one. Cancels that one. That one cancels that one. It's been a while since I've done the number line thing. That one cancels that one. That one cancels that one. So -6 plus 8 gives me a +2. Because you're putting them together. And when one's negative, you're more or less taking it away. It's the same thing as if you're saying -6 plus 8, it's the same thing as saying 8 plus -6, which is the same as x, or 8 minus 6. That's the reason they cancel. It just hit me. Another way to do this one on the number line. Call this 0 here. So I have 1, 2, 3, 4, 5, 6. This is -6. So when you're adding and subtracting on the number line, if you're adding, you're moving right. If you're subtracting, you're moving left. If you've got a negative number, you're going to the left. If you've got a positive number, you're going to the right. So I'm going to take my -6, and since I'm adding a +8, I'm going to move 1, 2, 3, 4, 5, 6, 7, 8, and I'm sitting here at +2. So that's would be my answer. So I go from the first number. Let's do a different one. Let's look at -12 plus 9. That's -12. So start at -12, and I'm going to move to the right 9 places. Um, 6, 7, 8, 9. And that leaves me with -3. So -12 plus 9 gives me -3. Positive and negative numbers are hard to deal with. And I don't, if the number line helps you, use the number line. If you can do it without the number line, do it without the number line. I'm not going to make you use the number line. So the next thing we're going to look at is if we have, it says determine whether or not x equals -2 is a solution of x plus 4 equals 2. So to determine whether or not this is a solution, x equaling -2, I'm going to put -2 in for my x. I'll do -2 plus 4 equals 2. Is that true? Because -2 plus 4 is true. So then -2 is a solution. I've got to go back and look at Ox for a minute. Bear with me.
I don't see a 7.2.
Well, that's what I was trying to remember. Because I skipped chapter 7. How wonderful is that? So anyway, that didn't hurt. This review didn't hurt, right? Positives and negative numbers never hurt to be reviewed. Okay, so we do have 8.1. So I'm going to look at 8.1. Make sure that I have. We got a better way to do this. Okay. So 8.1. We're going to solve linear equations. And a linear equation is x plus b equals c. So I've got two numbers I want to add together to equal a third number. But x is always an unknown. Okay. Another type you may see is a times x plus b equals c. Okay. So there's several of them we might, several different types. So if we look at the first one, I do x plus 5 equals negative 16. I want to know what x is, okay? And to solve this, I've got to get x by itself. I mean, we could look at it and say, okay, 5, and if I take away, I don't know, something, I'm going to get negative 16. But I can also do it this way, negative 5, negative 5. That way, positive 5 plus negative 5 gives me 0. What I do on one side, I have to do on the other. So I have x equals negative 16 and negative 5. Since they're both negative, my answer is going to be negative. Then I add 16 and 5, and I get 21. Okay. So to check this, I'm going to do negative 21 plus 5. Does that equal negative 16? And if it does, checks, then x equals negative 21 is your solution. I do want this really hard. How about x plus 2.7 equals 3.8? Okay. You're always going to do the opposite of what's with x. So if it's x plus a number, you're going to subtract that number from both sides. So I'm going to do minus 2.7 minus 2.7. So x is going to equal 2.7 minus 2.7 gives me 0. So 3.8 minus 2.7 is 1.1. Eight minus 7 gives me 1. My decimal comes straight down. And then 3 minus 2 gives me 1. How about x minus 20 equals 15? What am I going to do to both sides? Can I add the 20? So 15 plus 20 plus 35, right?
Yes.
The negative 20 and positive 20 cancel. So questions? This part seemed pretty easy if you don't overthink it. I'm going to throw a curveball at you. What if you have negative 5 plus x equals 7? I still want to get this x by itself. So I still got to do something with the 5. Since it's a negative 5, so what's the opposite of negative 5? Positive 5. So we're going to add 5 to both sides. So those cancel. X equals 7 and 5. It's 12. Okay. Not bad. What about 3x equals 10? So I don't have any addition in this one or subtraction. 3x is the same thing as 3 times x, right? Okay, so what's the opposite of times or opposite of multiplication? Division, right? So I'm going to divide both sides by 3, and you're always dividing or adding or whatever's with x. So 3's cancel. 3 divided by 3 gives me the 1x equals 10 over 3, or I can do 3.3 repeating. Figure Hawks will want the 10 over 3. So here I have 4/5 equals 3x. This one's a little bit different because it's got a fraction with it. What I'm going to do is I'm going to make my 3 a fraction by putting it over 1. So I'm still going to divide both sides by 3 over 1. So then I basically have 4 over 5 divided by 3 over 1 equal x, because the 3 over 1 divided by 3 over 1 cancels. Now, what do we do when we have two fractions that we're dividing by? Y'all remember the keep, flip, change? Yeah. We keep the first one, flip the second one, change it to multiplication, then we multiply straight across. So I'm doing 4 times 1 to get 4, 5 times 3 to get 15. And that doesn't reduce, so that's my answer. So I have 5x. That's one problem. Minus 4x plus 1.6 equals negative 2.7. So first thing we're going to do, since I have x's on the same side of the equal sign, so I have this 5x minus 4x. I'm not taking anything across the equal sign. I'm just going to combine them just like they are. So what's 5x minus 4x? It's the same thing. I don't like writing it like this, but it's the same thing as saying 5 minus 4x, because that x goes with both of them. So what's 5 minus 4? 1. So I have x plus 1.6 equals a negative 2.7. So now we're back to where we were. I'm going to draw lines. So now, how do I get x by itself? Subtract the 1.6. So x equals, all right, so since it's a negative 2.7 and a negative 1.6, they're both alike, so the answer will be negative, and then I'm adding the 2.7 and the 1.6. So 7 and 6 is 13. Decimal comes straight down. 1 is 2, 1 is 3, and 1 is 4. That's 4.3, or negative 4.3. I have the textbook. Okay. We still got plenty of time, but am I blowing your minds? Have I just kind of blown y'all out of the water? Are y'all still with me? You still with me? Okay. Sometimes I feel like I give you too much information and it's just like confuses you. All right, so if I look at the next one, this is 8.2. Here are my pens. Choose my pen. All right, so we're looking at 8.2, and we're going to still be looking at solving for x, but it's going to be along the lines of ax plus b equals c. Okay, so we're going to do more than one operation. We're going to do more than add or subtract or combine like terms. So if I give you 3x plus 3 equals negative 18, I want to solve for x, but I got to do two separate things. I want to take the positive 3.
We don't have an 8.2.
No, you want it in the homework. I combined 8.1, 8.2, 8.3, possibly 8.4 all into the 8.1 homework. That way you're not doing 107 lessons. I did 8.1, 8.2, and 8.3 in the homework. But this, in the textbook, this is 8.2 for reference. So I'm going to get the x term by itself. Okay, so your first goal is to get rid of whatever's with x, or whatever's with the x term. So I'm going to subtract 3 from both sides. So 3x, positive 3, negative 3 cancel. Negative 8, negative 3, it's going to make that a negative. Then 18 plus 3, 21. Okay. So I've got the x term by itself. Now I want to get the x by itself. So I'm going to do the opposite of multiplication again, right? Because it's 3 times x. So I'm going to divide by 3. I have to do it to both sides. My 3 is giving me 1x. Negative 21 divided by 3, negative 7. Do y'all like this better than the document camera? I kind of do too. Easier. So the next one is -26 equals 2y minus 14 minus 4y. Okay. So I have my y's on the same side. I have the 2y here, the -4y here. Remember, whatever this sign is in front of it goes with it. So that's the same thing as saying 2y minus 4y minus 14. -26. So I'm going to combine. I'm not taking it across the equal sign, so I don't, I'm not changing the sign. So positive 2 minus 4 gives me a -2y. Then I still have my minus 14, and it still equals -26. Okay. So we have to combine like terms. And as long as they're on the same side of the equal sign, we just add them or subtract them just like they are. So then what am I going to have to do next?
14.
So I'm going to add the 14 over. I'll add it to both sides. The 14's canceled. I have -2y. Then -26 plus 14, so I'm going to subtract because the signs are different. So 6 minus 4 is 2. 2 minus 1 is 1. And larger number is negative. So then my next step would be 1 -2 divided by -2. So y is going to equal positive 6 because a negative divided by a negative is a positive. So it sounds like y'all got this pretty much. Again, a lot of times it's just digging back far enough into your brain to find where you were, you learned it the first time. That's one thing I like about teaching the fundamental algebra, fundamental whatever this class is that y'all know this already. We just got to find it. Okay. So I'm going to throw you a curveball. This is the thing y'all don't like. Okay, I'm going to say you don't like it. Most people don't like it. And it's fractions. I'm going to do it a little bit differently than what the book does it. I mean, they're still using the same process. I just do it a little bit different. We've got to find our least common denominator. And I'm going to kind of take out the least. We have to find a common denominator because it'll work with any common denominator. So what is something that 6, 2, and 9 will all go into? What? 18. Because 2 times 9 is 18, 6 times 3 is 18. So my common denominator is going to be 18. So I can flip back and forth between pen colors. So I'm multiplying each term by 18 over 1. Book multiplies each side by 18 over 1. To me, that's a little confusing. So I like to do each term. I get the same results. Okay, and then I go back and I cancel. So 6 goes into 6 one time, right? 6 will go into 18 3 times. 2 goes into 2 one time. 2 goes into 18 9 times. 9 goes into 9 one time. 9 goes into 18 2 times. So what I'm left with is I've got 3 times 5. Don't forget my X there. Minus 9 times 5 equals 2 times 10. Since everything on the bottom is 1, I don't have fractions anymore. So 3 times 5x gives me 15x. 9 times 5 is 45. 2 times 10 is 20. Now we've got a problem like we've had, right? And we can solve it. So I'm going to get the x term by itself. So I'm going to add 45 to both sides. 45's cancel. So I get 15x equals 20 and 45 is 65. You're always bringing down that x term. And since it's 15 times x, I'm going to divide both sides by 15. And x equals 13. Now, if you need to do 65 divided by 15 on a calculator, that's fine. And I did 65 divided by 15, not divided by 5. So it's not 13. 65 divided by 5. Did I lose a negative? No. I didn't write the problem down the way it is in the book. So if I take 65 and divide it by 5, I get 13. If I take 15 and divide it by 5, I get 3. I'm reducing it to 13/3. So are we still okay? Maybe, maybe not. I'm going to open a new page. Make sure that I'm sharing the right page. So this goes on to 8.3. Again, but I have to choose my pen. Okay, so we're looking at 8.3. And this time, we've got equations that look like ax plus b equals cx plus d. So we're going to have a variable on each side. We're going to have an x on each side. We're going to have a whole number on each side. So it's just adding more steps. So the first one is 5x plus 3 equals 2x minus 18. Now, I'm the type of person that I want a positive x because I lose those stupid little negative signs. I drop them. So I'm going to look. I've got a 5x on one side and 2x on the other. If I subtract 2x from both sides, I'm going to get a positive answer, right? Whereas if I was to subtract 5x from both sides, I get a negative x. So I'm going to subtract 2x from both sides. It does not matter. I can subtract the 5x from both sides and still get the right answer if I didn't lose the pesky negative sign. So 5x minus 2x gives me 3x. I bring down my plus 3, bring down my equals. My 2x is canceled. And I bring down my negative 18. So now we're right back where we started, or right back where we ended in 8.2. I want to get the x term by itself. So we're going to subtract that 3. So I have 3x equals negative 18, negative 3. They're both negative, so my answer is going to be negative. 18 plus 3 is 21. And then divide by 3. So x equals negative 7. Any questions? Y'all got this. You don't even need me the rest of the time, do you? Here's another example I want to show you just to remind y'all. So I have 2, and then in parentheses, I have y minus 7 equals 4, and then in parentheses, I have y plus 1 minus 26. Okay, so we're adding a step to it again. When you have a number outside the parentheses, you're going to take that number and you're going to distribute it to each term on the inside. So I'm going to do that with both of them. So I'm going to do 2 times y, get 2y. 2 times negative 7 and get negative 14. 4 times y, get 4y. 4 times 1, get 4. And then my minus 26 is just going to come down. Then if I've got any like terms on either side, you know, the 2y minus 14, they're not like. I got 4y, a 4, and a negative 26. Well, my 4 minus 26, they're considered like terms. So I'm going to add those together first. Bring everything else down. So 4 minus 26 is a negative 22. So now I'm just back to where I was on that last example, where I started on that last example. Which one do you want to subtract, the 2y or the 4y? It doesn't matter. We'll go either way y'all want to go. Subtract the 4y. So if I subtract the 4y, and those are going to go away. 2 minus 4y, and y'all got to help sure make sure I keep my negative, okay? It's going to give me a negative 2y. So my minus 14 equals a negative 22. Okay, so I've got a negative. I can't lose him. All right. So since y is over here, I've got to add the 14 to both sides. So I've got negative 2y equals, to be able to do that in my head without thinking about it, negative 8. I'm going to take this up here and finish it. So I have negative 2y equals negative 8. So I'm going to divide by negative 2. Y equals a positive 4. How we doing? Okay, I'm gonna stand up for a minute, walk over to the board. Ow. Okay,
I would like to do like, 26.
this, the positive, the 4 minus 26.
Yeah.
When I do in my calculator, or I'll look at it as, I can do 26 minus 4, but my larger number is negative. I'm going to get, because 26 minus 4 is 22. So these are on the same side of the equal sign. So I'm just going to combine those.
Oh, because I'm the same sign to add and different signs to
Right, if the signs are the same, you add. But since this is a positive 4 and a negative 26, then I'm going to subtract, take the sign of the larger. Okay, that makes sense now? I'm glad you asked that question. I needed to stand up. I got time. I need to do a couple of more things. We're going to do another one that's similar to the one we just did, but it's 3. So it's 3 times x plus 5 plus 1 equals negative 11. Okay. This is the one I thought it was. So we're going to distribute this 3 to both terms. So I get 3x plus 15, 3 times 5 is 15, plus 1 equals negative 11. And then I have like terms. I have the 15 and the 1 on the left side. So they're both positive, so I'm just adding them. So I have 3x plus 16 equals negative 11. I'm going to subtract 16. 16 is canceled. 3x equals, so negative, negative, my answer is going to be negative, and I'm just going to add them. So I have negative 27 divided by 3, x equals negative 7. Those are ones that we've just been doing, right? There's types of these types of equations, and this one is a conditional. Yes, 3 times 9 is 7. Thank you. But it's conditional in as there is only one solution for x. Okay. I have 1x, I have only one solution for it. And then if we have 3x minus 75 plus 3x equals 65, okay? So what am I going to do on this equation? Just going to combine like terms, right? I have the positive 3x I wrote my equation down wrong. So that should be 6x plus 10. I apologize, wrote my equation down wrong. So 3x and 3x, that gives me 6x minus 75 equals 6x plus 10. Okay. So I want to get my x's together. I always want to move my x's first. I'm just that type of person. Get rid of the heavy stuff if I can. So I'm going to subtract 6x from both sides. So 6x minus 6x gives me 0. 6x minus 6x gives me 0. So I end up with negative 75 equals 10. Can negative 75 equal, what happened to my x's?
Aren't you supposed to at least put the x, keep one?
Because if, you know, I got a positive, I'm subtracting 6x, right? Let's think if x's are apples. If I've got 6 apples and I eat 6 apples, I have 0 apples, right? So I wouldn't need the apples there. So same thing works with x. All right. So this is called an contradiction. Mainly because it's not true, it's false. Because negative 75 does not equal 10. It's a contradiction. With a contradiction, both your variables disappear and there's no solution because you no longer, for one thing, you no longer have a variable. And the numbers don't equal. So, and then the last one, I have negative 2 times x minus 7 equals, oh no, not equals, plus x equals 14 minus x. Okay. So if I distribute the negative 2, get negative 2x. Now, what happens when I do negative 2 times the negative 7? I get positive 14 plus x equals 14 minus x. So again, I got my 2x and my 1x. So I'm going to combine like terms. Negative 2 plus 1 gives me negative x plus 14 equals 14 minus x. Okay. So again, I've got to combine my variables. So I'm going, since it's minus x, I'm going to add x to both sides. So negative x, positive x gives me 0, so I'm left with 14 equals, bring down my 14, negative x plus x gives me 0. So the difference between this one and the one I just did above it is that 14 equals 14. This one's called an identity. And there's infinite solutions. Because my answer, even though I don't have an x, 14 equals 14. So the left side equals the right side. So it's a true statement, makes it an identity. Identity means that, you know, that you've got the same. So I have infinite solutions. Anything I put in for x would work. Okay. Now I've overwhelmed your minds. Maybe not. All right, but I'm stopping for here today because that's the end of what your homework is on 8.1. Okay. I will find out a way to be able to save these pages too. The writing on them.